say hi. My name is Brad Pillow. This is our fourth Indianapolis.net Mobile Developers Meetup. Tonight I will be talking, or be doing an introduction to Xamarin.Forms with a little bit of F# in it. To begin, I'll get the slides going. We're going to do two pieces. One, Xamarin actually has a pretty good slide deck. There was no point in me actually reduplicating that. So the first part of that is, the first part of this presentation is their deck with my audio and a couple annotations on it, and then the last part are some slides that I added in on my own for a little bit more interesting information. So I'm down there, their thing, I cut out some of their slides at the beginning because we already had that kind of go through Xamarin tools, everything else, because that was our 2-3 meetups ago. We kind of went over the tools, but in case you're unfamiliar, just a quick overview again. Xamarin sells a set of cross-platform tools that run on Windows and or Mac, allow you to write in C# and or F#, and develop for iOS, Android, Mac OS X. They don't handle any of the Windows Phone stuff. They leave that up to, or any of the Windows platform stuff, that's left up to Microsoft. They have their own IDE for both platforms, but you can also, for a premium, pay to get plugins that work within Visual Studio over on the PC. There is a cost to this. It's not free, and it's not cheap depending upon your perspective viewpoint. And they recently changed their pricing model too, which if you haven't read about it, they basically have a free version you can download for 30 days and run. It only allows you to compile up to 64K of something or other code. It's fairly small. It allows you to do a simple hello world, and that's about it. But you can at least check it out and see what it's like. You can also take that, bring it down, and get yourself a free C# t-shirt or an F# t-shirt if you like this. You can follow the instructions off their website.
Mine hasn't arrived yet.
Yeah.
Otherwise, I would have worn that one.
I just did a thing for mine the other day. So.
Yeah. So if you want to enhance your t-shirt collection for free, that's one of the promotions.
But they're quite comfortable.
They are. They're nice. They're nice shirts. I think I've got to submit a few more under different emails to get all the colors.
I think my wife might become a developer pretty soon.
There you go. There's a whole closet full of C# t-shirts.
False.
The next price up is a thing that they just changed. It was $2.99 per year, and so you understand that it's $2.99 per year per mobile platform and per desktop platform. So it starts per developer, yeah. So it's the multiplying factor that kind of really bites. So if you're used to getting something like Visual Studio and building all the different Windows stuff, it doesn't work quite that way. They recently switched that to be a monthly fee for $25 a month, which it ends up being effectively the same number of dollars per year. Yeah, he's got it there. The thing that they changed a little bit, which was different that I didn't like, is the $25 per month one. You can start and stop at any point in time throughout the year. The issue is when you stop paying that $25, your tools stop working. So your apps keep working, but you can no longer develop any new applications. The $2.99 one you could buy, and then you could stop the yearly updates if you wanted to. Although if you're actively developing, you typically don't want that. You just wouldn't get any new updates. But with the new $25 one, you have to go continuously or your development stops. They have a business one that is $8.99. That one gives you the plugins for Visual Studio, which is nice if you're developing on the Windows platform. But again, the issue becomes it's time for me to upgrade again in October. Most of what I'm doing right now is Mac OS X and iOS, just on Mac. So I will most likely do the Indy, cancel out the rest, and just do those two, which is $50 a month. But if you wanted Android too, it's $75 a month. And if I want to throw the PC in, which is what I did before, yada yada, you can see where this is going. So unfortunately, you can't do this as a hobby kind of thing for programming, just for fun. Or you can if you've got a good bank account. but that is the one problem they have. They do have a thing that if you are developing an open source project and you can show that it's open source to them, they will give you a license for development of it. I'm not
Can it only be used for open source or?
Technically, I think that's the way it's written. So I don't know if you could potentially do an open source thing, get it, but I think I read the legalities on that, and I'm pretty sure it was, you can only use that. You need to buy a truly licensed one if you're going to actually make commercial software. Drafts, no loopholes there. So, okay, so the traditional approach, and this is what I was doing up until in the last few years, longer I guess than Monotouch, is you actually had to build a C# shared backend, and then you had to build your user interface for each platform. And I do stuff over on Mac, so actually another one. That was doable, but it was a lot of extra work. Still a lot less than building an Objective-C version for iOS, a C# version for Windows Phone, a Java version for Android, but it still was a little bit of a pain. So there'd been another guy who had developed a thing called MVVM Cross that tried to ease some of this, and he'd started to move into the UI space a bit too on that. And Xamarin came out with Xamarin.Forms, which is free, as long as, of course, you buy into Xamarin. And in that mode, what happens is you actually have shared UI code. Basically, it's a framework I'll go into that allows you to have one common set of code that does the UI, that handles all the platforms, pretty much. They basically have come up with some metaphors that handle the various types of things that you do on the different platforms. And what it's actually calling into is all the native UI. So they do look native. Sometimes you do have to do a little bit of tweaking, which I'll get into, just because UI guidelines on different platforms specify how close buttons should be, and text of buttons, and text size, and things like that. This doesn't really take care of that, but it takes care of the overall UI. Slide. Okay, so what's included? 40 plus pages, layouts, and controls. That's all of those added up make 40. You can build from code behind. If you're used to old Windows stuff, that was the term for building your UI in code. Or you can use XAML. XAML, not to get too confused by it, is really just a big XML file. Microsoft came up with their own namespace. That's at the top of these XML files that makes them XAML files. And these guys did the same thing. They used basically a similar format that declares slightly different namespace for the XML. And you can describe your UI in XML, in XML or XAML. It's a little bit of a pain right now. The reason that you would do that typically on Windows is most people didn't actually edit XAML by hand. Usually use the UI designer, and then it maps it all for you, and that allows you to have designers working on the layout and everything else. They do not have a UI designer for this yet, so if you want to use XAML, you have to do it by hand. I don't see that there's a huge advantage over doing it in code, because if you do it in code, it's actually type checked and you get errors, as you're typing everything else. XAML is sort of a run it and see what happens. There is a guy that has written an app for iPhone. Well, it's written in the Xamarin.Forms. This is called XAML Previewer. It just allows you to send XAML to your phone, kind of preview things. So if you want to work on it, I suspect that probably in the very near future they'll have a UI design. At which point, then working in XAML will be a much more reasonable thing. It supports two-way data binding, so binding your controls into your data, so that when you press a button, something gets called over here. When I enter text over into this field, it actually gets updated over in some data structure that I have. And two-way being that the data structure can modify the UI, or the UI can modify the data structure. It supports navigation. That's the big thing about all of the phones, basically, is you're moving around from pages and you're going back. Same kind of thing like you do on a website, and they basically abstracted out the navigation, which is ever so slightly different amongst the three different phone platforms. They've added in an animation API, which is nice, so that you can have things that bounce and fly around and do things that people like more these days. I started to look, and I haven't checked to see if that actually calls into the underlying animation APIs. iOS, they have some fairly optimized animation APIs that you really want to use for performance. You, of course, can just go and tell a UI control to change its position and size, and if you put that on a timer, you'll end up animating those things. That's not necessarily the most performant thing. I'm not sure which they are doing right now, so the performance may vary. They also have what they call a dependency service, which is I'll talk about a little bit later, is really just a service locator pattern. It's just a way of providing abstract capabilities that you might have that are platform specific on each of your platforms back into the shared C# backend. We'll talk about that in a minute. They have a messaging center. Some people also call them message buses. That's basically so that one part of your app can broadcast a particular message, other parts of your app can subscribe and act on those messages. It's very good for loose coupling applications. It can be rapidly abused if you loose couple things too much, then suddenly no one can figure out how your application works or how it hangs together. So, but it is handy for a lot of things. The next page. Here we go. Pages. Okay. They have called these. You have defined these things, and they call them pages. It might be called view controllers on other platforms. They might be called different things. This is their standard set right here. There's a content page, which is pretty much just for just various content that you're going to put. It's a main page. Master detail is the one that you're more familiar with these days on the phones, where you've got something that you swipe to the right, and the menu comes in from the left-hand side. It's popularized, I think, first on iOS. Android has it. I assume it's on Windows Phone too, though I don't have one. There's the standard navigation. I'm going to go to the next page. Next page, I'm going to go back, and pop. This is fairly common on all three platforms. How you actually move back. Some have soft buttons, some have hard buttons, different things. Those are a little bit different, but in general the same. A tab, so basically tabs across the bottom, select different views. A carousel, which is swiping left to right to see different views. So these are your fundamental ways of assembling your UI into pages. And that was a bad keynote thing of mine. They also have layouts, and those are the mechanism for laying out dynamically your UI. iOS has a thing called the auto layout, and it had the old spring instructs thing as well, which is not very powerful. Those are mechanisms for just getting your UI on the screen. Their standard ones are stack, which basically allows you to take UI elements and stack them one above the other, or stack them right to left horizontally. You have some options that allow you to say interspacing, whether to center, things like that. But basically those are linear up and down, left, right layout. Absolute, you give it pixel coordinates. You don't need to use that. But it's there in case you need it. Relative is pretty close to auto layout. It's also, I think, called relative layout on Android. Basically allows you to add constraints. I want this button here to be at the bottom of this button and centered with this button, and its width should be equal to, you get the idea. You can set a whole bunch of constraints. This is the most sophisticated, allows you to do the most UI that can dynamically adapt to different phones, iPads, things like that. It seems to be the hardest for people to wrap their heads around. So auto layout has been on iOS for a while. I haven't seen that many people use it until just recently. So, but it does give you the most flexibility. Grid is pretty simple, just like it says. You basically specify, and the grid's also over on Windows Presentation Foundation. You can go to Windows.Forms, even add it. Basically, you can specify that everything is in an N by M grid, and then each of your UI elements, what grid part it's in, and then how many grid elements it spans. So it works pretty well if you've got things that are laid out in a nice form like that. Content view, this is typically just used as a base class for other views, other layouts. Scroll view allows you to have elements that scroll up and down, left, right. And then frame is basically just puts a frame around the things that are in your, I think that's what that does. Can't remember. I don't use it. Around your user elements, UI elements. And they have controls. So this is their current list, and it's fairly comprehensive. It covers pretty much all of these map typically somewhere into all the other phone views, with the exception of this one. OpenGL does not exist on the Windows phone, so you can't have an OpenGL view. But it does exist on iOS and Android, and it's the typical way if you're going to put some kind of game or high-performance animated view inside your UI. Activity indicator, swirling little things, text entry, step up and down. I've got some examples of this in a little bit, and I'll show you. But as you can see, it's fairly comprehensive. So maps allow you to bring up whatever the platform maps is. Google Maps on the Android, iOS maps on the iOS, and I have no idea who provides the maps on Windows Phone. Bing, okay, that's right, Bing Maps, that makes sense actually. So you can always bring up a web view, which is nice if you got to have some content. So basically you've got those three things: pages, layouts, and controls, and that's all of your UI. So these aren't actual demos. Since I swiped this from Xamarin, these are actually pictures. But basically, if you're familiar at all with the Windows platform, model view, view model tends to be the standard instead of model view controller, which was promoted by Apple. It's probably too hard for me to actually go into the whole details of how that works right now, because sometimes it seems like people get confused as to how that works. But the model is basically the data that you have for whatever you are presenting. If it's a bunch of list of tickets, then this is going to be a list that has the tickets, the venue, the pricing, things like that. The view, of course, is the UI, the part that actually displays the tickets. The view model is effectively, you can think of it, sits in between these two. Basically, you don't want to have all of these things. You don't want to have the model dependent on the view, largely because I might have a model over here, a list of tickets, and I might want to show it as a linear list of tickets, but I might want to show it as a grid of tickets. I might want to do various things. Those would be different views, so we don't want to tie these together, otherwise then you can't do that. The view model sits in between and basically manages communication back and forth between these two. So as it says here, view is how to display the information. View model, what to display, flow of interaction. As you'll see here, it basically shows what happens here. The view is sending events. I clicked a button, I entered some text to the view model. The view model is sending back potential data to be displayed. They come over here, and then the view model just sends back and forth data to the model, although actually you can have some sort of pseudo links going that way too. But the whole idea is to separate these things out to allow reusability. It's just another picture. Okay, so there's a thing called Xamarin.Forms data binding, and that's where that comes into this part here. It allows you to take your view and connect it up to a view model, or basically a thing that's going to handle interaction to from the view. I click on a button, I want it to call a method over in my view model. I have some text here, I want it to update the text field in my view. So that's where data binding comes in. And if you are familiar at all with Windows over the last decade or so, they got really big on all of the parts of it using notify property change. And this is basically how you tell that something has changed in your view model. It's a lot of boilerplate code. There's lots of ways around this that are better. But basically, the idea is when I change something over in my view model, I'm going to call something that says my object has changed, and I'm going to send an event that says that I have changed, and I'm going to give it a name. So the number of tickets has changed. So when I update the number of tickets in my view model, I'm going to go and run through this code here and basically send out an event that says the tickets have changed. And in this case, the data binding, the view is basically listening for that event to see if anything has changed and whether it needs to update. So this is view model here. This is one of the properties. So instead of ticket, this is first name here. And basically what's happening is, hopefully you know how C# properties work. They're just abstractions for wrappers around what look like variables. So we get the first name, the underlying first name, when we're going to set it. If the value has not changed, then we'll just return. If the value has changed, we'll update the value, and we'll send out this message that says first name, this magic string, has changed. And then the view that is listening to this can do something with it. And in fact, this is the Xamarin binding, data binding right here. So if we've got a label up in our view, first name equal label, you can have some initial text there. Then we can basically say the first name, we want to set the binding. So we want to set the text property of this label to be bound to first name. First name is basically this property changed events magic string. So what will happen is this binds the two together so that when one changes, so that when the first name changes, the text property of the label will update. The beauty here is that all the UI elements that are in Xamarin.Forms have a whole bunch of properties. So it could be the text, it could be the size, it could be the font. There's all kinds of weird properties on each of the elements. And that's how you basically bind to different things. And this is, that basically sets a binding. This is another example that basically allows you to do two-way binding. So that's this one here, this user view model here. We basically have created a new entry, which is one of these. And we're going to take the text property from our view model, and we are going to bind it two ways. This nomenclature right here, this is a lambda, and basically it's a way to get around this magic string. So in C#, not going into details, basically when you do this internally, it can look at this snippet of code, if you want to say it that way, and pull first name out, even though that actually is an actual property on here, so it's type checked. It can actually pull it out and figure out what the string is behind this so that it can actually do this binding up here. The place where this is all fragile is if you change this name and change that name and you don't change that name, your binding will go away. So it's not a way that I like to do binding. And there are alternatives, but it is the way that Windows has done it for eons. And it's the way that they did it. There's various GitHub things on these demos, so you can go up and hold them down later if you want to play with them. This is a stock app. This allows you to look up stocks, but that gives you an idea of iOS, Android, Windows Phone. Basically the same app, it will largely end up looking the same. Okay, so extensibility. This is important. They've got 40 pages, controls everything else. But, you want that, one finger slide, spin around dialer thing, and suddenly, okay, now I can't get cross-platform anymore. I've got to write this thing. That breaks everything. Well, they thought about that, luckily, and they allow you to have what are called custom renderers. So every UI control that they've already written has a renderer for each platform that basically says, if I've got a button, here's how I render it on the iOS, here's how I render it on the Android, here's how I render it on the Windows Phone. And they have a mechanism for installing those renderers so that when you are writing your cross-platform UI, you can call those renderers as abstract things that are cross-platform. When you get to the platform, it will pull out the underlying correct renderer and render the correct UI. So it allows you basically to customize your drawing, your UI, and also allows you to customize the bindable properties. That was the last slide. Basically, we have labeled a text property. so that you can expose different properties. So if I make a dial, then I can basically expose things like the value or the angle, or if I want the hue of the dial to change with the angle or something, I can expose all those properties, which you can bind to something in your UI. They have a pretty good guides on how to actually create these, and there's actually sample code plenty that they have on GitHub that shows you how to make your own little controls. The standard entry control is just for inputting text. They're just showing you this extensibility, the standard text field. Here's an entry field, type in shared code. So basically what they're going to do is they're going to make a custom forms control. So the easiest way to do that is to extend something that is close to what you want to have. So if you're just drawing something, you can extend, I think there's a box control, or you can start with a button if you've got a fancy button control. Whatever, that way a lot of the behavior is already the same. You don't have to re-implement all the behavior. So this is an example of using a created custom control. This right here is an example of, rather than XAML actually laying out your UI in code. So they're actually using here, they're creating a custom control. And this is the renderer for my entry, that part there, that's the custom control they've created. So basically you get a bunch of methods that you have to override that basically say I'm drawing, my properties have changed, okay, then I've got to go look at the properties, see which ones I need to change. And you create one of these for each of the platforms. So if you notice this is a UI text field, this is the iOS version here. So if you create a custom renderer and you do not implement the renderer for all three platforms, then basically what would happen is on the other platforms, since this is subclassed from the entry renderer, you just get the standard entry renderer on the other platforms. So that allows you to kind of get going quickly. If you want to initially get fancy renderer or something up on iOS, you can get there first. You still run your app on the other platforms, you just won't get the cool stuff. So they've got a lot of examples up on GitHub how to do that. You then have to export the renderer. This basically goes, as an annotation, goes above your code, or basically this, when the Xamarin.Forms runtime gets going, it will go and collect all of these guys and register them so that it knows that you can actually use the my entry as a UI element. Okay, so that's custom elements. Extensibility also, they have a thing called a dependency service. So, let me back up just a little bit. The thing that has made all of this really possible is a thing called portable class libraries, which came out about 3 years, probably 3 years ago. And these are .NET DLLs that basically can run on multiple platforms. The way they do that is they basically neck down and narrow down the number of .NET APIs that are available, and by doing that they create different portable class library profiles. So this profile over here supports these two platforms, this profile supports here. The more platforms you support, the narrower the number of APIs that are available, because it's basically looking at the intersection of all the platforms. The most recent one, and the one that all of this is contingent upon, is a thing called Profile 78. 78 allows you to go to iOS, Android, Windows Phone, Windows Store, Mac OS X, and .NET 4.5. So basically that covers pretty much everything. And the kinks in that have only, in the last, C#, the kinks have been out for 6 months to a year. F#, the kinks only got out very recently. But the issue there is, since you have necked down all these APIs, you might suddenly find out that you want to use, I'll give you an example, reflection, looking at a program and getting metadata about the other code. When you neck yourself down, you don't suddenly have a lot of the reflection APIs. So the problem is you still want to use those. Another issue is I want to use Core Motion on iOS. That allows you to track basically the number of steps you're taking, things like that. There's an equivalent one for Android. I'm sure Windows Phone, if they don't have one, will have one. You want to use that. Xamarin doesn't support it yet. So you want to somehow provide these so that your class library that you've written that is cross-platform can access these things. But since they're all slightly different, you can't call them directly. So the way that you do that is what they like to call a dependency service. As I noted down here, lots of debates on things like this, but this is typically known as a service locator metaphor or pattern. The idea is, look over here, I think the next one, you declare an interface. Okay, if you're familiar with C# interfaces, this is basically saying, this doesn't do much itself. This basically is just saying that if someone subclasses this interface or inherits this interface, that they have to provide this functionality. But this is the mechanism by which you get your code working cross-platform. You basically then, in your cross-platform code, you always write to iText-speech interface. And then for each platform, you provide a concrete text-to-speech implementation, like so. So here's iOS, we want to speak something. Here's how you basically do it. So you create your class over on iOS, you descend from iText to speech, the interface, you implement it, and you repeat for 3 platforms, and then just like we did with the custom controls, you basically add this right above your code, and that registers that service as one of these guys, iText to speech. So then later, you can basically then go and use this thing called a dependency service. So if I just say dependency service.get iText to speech, it will go find, for each specific platform, it will go find this code back here, and it will basically construct one of these guys, but it will construct the native version and give it back to me. But since I, on the portable part, only know about iText to speech, it doesn't matter. I'm only going to be talking iText to speech, but underneath, it actually is the native part for the platform. This is the way that you also get around portable class libraries where you need to get to things like reflection or some other .NET API that does not exist because the APIs have been necked down. Dependency, like I said, is a little bit of a misnomer here. If you look at IOC and version of control, larger dependency injection systems, you're actually, the whole idea of those is that something depends on something, which depends on something else, which depends on something else, and it's kind of assembling this graph of objects and constructors. This is dependency, but you're really only one level deep. It's too hard to get into IOC in this talk, but the beauty is there are a lot of other third-party IOC containers that you can actually get to use to work with Xamarin.Forms. The big thing is, just like the property notification, several of these things, Xamarin didn't want to go over the top and create super complicated things because number one, they'd scare off half the people because some of the IOC containers that are out there take a little while to figure out how to use. So basically they wanted to provide some stuff that would handle the 80% of the case, leave the 20% to everyone else. So this works fine for a lot of things, and for most people it will probably be totally good.
So you're saying the third-party IOC containers are a replacement or augment the dependency services?
You can replace them, and you can get them to work with it. There's a couple of people that are working on different adapters, kind of adapter libraries to get them to work with it. That's all just sort of, people are just kind of experimenting around with that now. You can obviously use another IOC container. There's nothing, internally, Xamarin depends on the dependency service for their controls and things, but that's just calling their own services. So you can throw another IOC in there and use it independent of that. Theirs will still be there, it'll still be used, but it'll be used for their own.
Do you have do you know how extensive their dependency manager is?
That's it, that's it. It's just a service locator. All it allows you to do is
That
look
one's
up.
basically useless.
Yeah, it's all it allows you, it just allows you to expose a service that's
Yeah, so
mapped to an
it's a-
interface, that's it. There is no actual.
Singleton, it's basically a singleton.
Yeah.
It's,
Yeah, I'm
it's,
sure you're gonna talk
there's-
about Xamarin.Forms Labs, which will let you map to Ninja.
Yeah, and there's
Mighty
another,
IOC.
there's an open source project that basically has the top 4 or 5 IOC containers that they're working on, nice mapping of it. So if you're doing lots of classes and or if you're familiar with using IOC, that's not going to do anything for you. It's part of it is just for exposing simple services, like text to speech or something that are platform specific. That's really why they put it in there. And that demo, if you go over there, you can see the demo is it's the same as the previous demo of the stocks. It just says hi. Apple is $103.35 or whatever. They also provide, which is nice, which I mentioned earlier, an animations API that allows you to do cross-platform animation. It's kind of, I didn't realize I had it animated in here. Again, I'm not positive on these animations if they're using the underlying, I haven't even looked at that, I have it right. iOS has a really nice thing called core animation, and I'm hoping it's calling down to that. If it's not, then it's not as performant as it could be. Sorry, iOS, going to the wrong thing. I don't know what Windows has. Windows Phone. Do they have an animation?
They've got something.
Something, yeah. I mean, it's part of the whole WPF-ish kind of thing, so. Okay, so here's the animation thing that you basically saw there. So it's using a lot of async await, if you're familiar or not familiar with C#. Most recent versions allow you to do much more simplified asynchronous programming through the await keyword. And too long to go into exactly how that works here, but basically it helps you write code that is not blocking, which is a bad thing on a phone. Bad thing on a desktop, it's even worse on a phone. So what this allows us to do here is basically write some code that says, let's do each of these animations in sequence. The problem is, of course, if we did this without async await, we'd be looping in this loop that says for 1 to 3 seconds do the first animation, for 3 to 6 seconds do the next. But basically the rest of our UI would become unresponsive. Async await basically allows these things to get spawned off, and basically the phone OS, whatever it is, basically goes back to the event loop. So events keep still getting handled while the animation is going on. And then once this is done, it returns back into this piece of code, executes the next, executes the next, executes the next. So basically these are allowing you to do things like animate the color, the size, the scale, the position of different objects. I haven't played with this animation API a lot. They've got the easings, bounce in out, spline stuff. It's pretty handy. It's kind of nice to, if you look at some more of the iOS animations, people are beginning to do applications. People are beginning to do more subtle animations just as things to give people feedback, or at least more entertaining feedback. Go through that. Back to that again. Okay, so navigation. Basically, we are moving around through different pages or views that we have. So they've got a root page that basically allows you to give each page this iNavigation interface. That interface basically allows you to say on any page, I want to push async to another page. So that's when you've got your little to-do list here, and you click on your to-do item. Basically, that page is going to go to the left, and the new page is going to come in. That's your to-do item page. This is all based on the async await stuff in C# as well. You want to do these async, so that pushes async and immediately returns. So again, you don't block your UI. You can pop async, so all your navigation is a stack, just like you're used to on web browsers. And all the phones pretty much implement this sort of push and pop stack. These two are basically for modals, so when you're going to bring up your dialogues or alerts, things like that. Let's see here. So as I mentioned, they have a messaging center. This is a very primitive, simple messaging center as well, just like the dependency service they have. So this allows you to basically send and subscribe. So you can have an object that basically subscribes on a magic string, and when it receives that magic string message, it does a particular callback in action. The messaging center can send the item. These are basically generically typed. Send the item based on that message. Again, this is strings, so it's kind of a little bit fragile. It works. It's a messaging center that handles a lot of what people use. Some of the other frameworks have better messaging centers because many times you want to filter on messages, you want to trap messages, you want to turn off certain classes of messages, things like that. Within your system, you can't do that. These, again, it's really great for basic, probably covers 80%. Here's an example here, messaging center. We're going to subscribe on this type, trip expense. Whenever we get the add new message, it's going to basically call this lambda here, which says expenses add. Somewhere else, someone is going to say, oh, they typed the expense in, so let's send the expense. We'll do the add new, which gets picked up here and executed here. Pretty straightforward. Resources, these are all of the links to their documentation. Samples, they have a whole truckload of samples. That's probably one of the best ways to learn a lot of it. I mean, they have really good documentation too, but I'd look over all of these beyond the intro. So any questions on that before I go on for just a little bit more? Good? Okay. I know I'm kind of going quick, so I'm not people confused. So model view model, as we talked about earlier, the built-in stuff they have does allow you to do model view model, but it's pretty primitive. So there are a lot of other approaches. My favorite is one called reactive UI that is basically, it's linked to a thing called reactive extensions. If you're not familiar with reactive extensions, it's a really cool technology from Microsoft that they unleashed on the world too, so you can actually use it on all the Xamarin. Easiest way to think of reactive extensions is link over events. So if you know what link is and how you can basically write various queries that almost look like SQL over data, reactive extensions are the same thing but over events that are happening in the system. It allows you to build more composable pieces of code for user interface. This guy also has a really nice message bus that is strongly typed and a little bit fancier. He also has slicker property binding that doesn't use magic strings anywhere. It's got a bunch of other features. It's got some nice features for automatically handling, transitioning to new views, and automatically doing the push and the pop. This reactive UI can be used with pretty much any of the. It can be used with the standard Xamarin Touch Android, but most recently they updated it to work with Xamarin.Forms. It's really nice. But a lot of people find reactive extensions very confusing. So, just your mileage may vary. It's my favorite. MVVM Cross was a very popular framework before Xamarin.Forms came out. It still may be very popular, but I'm sure a little bit of it changed once Xamarin.Forms came out. This website here has an example of trying to meld the two together. I haven't actually played with it. Did you actually play with it, Dale?
I play with that.
It seemed to...
And it works.
Works, okay. So, if you have been using MVVM Cross, then you might like something like this to bridge your efforts. Since they're kind of overlapped and doing a lot of the same things, I think it's easier to go to something that's not mixed in. This is something I ran across recently that I thought was really cool. It's a project called Fody, or Fody Weavers. This is basically a piece of software that does weaving of your CLI code after compile. So basically, it can go and when you're compiling, it can go and make modifications to the code that's being compiled before it's actually finally written out. And they have a really slick thing, which is called property change notification weaving. So you add this in, and it works, believe it or not, in Xamarin and all the different platforms. And you can basically then add an annotation to a property, and when you compile, it will go build that massive stuff that does the on notified property change and did the change and all that. It actually builds it behind the scenes for you. And it turns out they've got a whole ton of other plugins for this that do some really cool things. And I don't know how I missed this before, but it's pretty slick. And this one right here is a blog entry that basically tells you how to use this property change plugin with Xamarin.Forms. So it's pretty cool. MVVM Lite is another, this is originally a Windows only MVVM framework, but they have also modified it for Xamarin.Forms, etc. It's a kind of like the MVVM Cross, but it's like much smaller. This is Xamarin. This is another one. It's F# only, but I stumbled across it. It had a couple of cool things in the projects that allowed me to figure out actually how to make F# and Xamarin.Forms compile. He had figured that out somewhere along the way. They had figured that out somewhere along the way. It is MVC, so depends if you like that or not. But that's the GitHub link to that. Here is a bunch of sample code that you can find. There's a ton up on GitHub. If you start looking, there's bunches of samples. Some are better than others. This one, Run Tracker, was kind of cool. It's a jogging tracker. It was kind of nice because it actually shows you how to do use some native stuff, in this case core location, because they want to track where you're running, SQLite, which is good, and relative layout, which is the constraint-based UI layout. This is handy Xamarin Control cheat sheet. If you're just suddenly working cross-platform, this has basically the different controls, the different views for each platform, and is the Rosetta Stone of, when I say this over on iOS, I mean one of these over in Android, I mean one of these over on Windows Phone. So it's just a little PDF, it's kind of cool. Draw It is a very simple doodle program, but it's nice because it actually shows you how to do some custom controls for getting to some drawing things that aren't built into the Xamarin framework. CrossChat's a very nice chat application that runs cross-platform. It's a really good example. This one right here, Xamarin.Forms Reactive UI example, is very basic, but it shows you how to use the reactive UI that I talked about a minute ago with Xamarin.Forms. And then this is a recent blog entry that basically shows you how to actually get Xamarin.Forms to work with F#, which, when you actually finally see it, is fairly trivial, but there was secret sauce involved, which no one seemed to know until recently. So, excuse me. Useful PCL libraries, portable class libraries. Splat is a really handy one. Paul Betts is a very prolific writer. He works for GitHub, and he does the Mac GitHub app, and he's done a bunch of other stuff. He writes a lot of code. Splat's really nice. It basically does cross-platform homage. Okay, image handling and geometry. He's just adding in cross-platform logging library, a few other things. So it's really one of those sort of just handy utility baskets of things that work cross-platform across all the different profiles across all the different platforms and profiles 78 supports. Akavachi, if that's how you pronounce it, is a asynchronous persistent key value store. Basically, it's layered on most of the platforms on SQLite, and basically what it allows you to do is a key value store. So if you're familiar with, that's like a map, a dictionary. Basically, it's asynchronous persistent, so it stays around until the next time your app comes up. When you make the calls, they're asynchronous. Why do you use this thing? You use this to cache things. So you're pulling down web pages, data from a REST service, things like that. You use this to cache things, keep your app responsive, and keep it persistent. And it is also PCL, so it runs on all the platforms. Fodi is the one that I just talked to you about with the .NET, weaving the .NET assemblies. It's really pretty cool. Check it out. System.drawing, they don't have this working yet, but Xamarin is in the process of porting System.drawing to each of the platforms. So they just finished the one for iOS, but they're doing it for Android, and of course it's already sort of in partly in a Windows Phone. The idea is that you can write your graphics. I want to draw a graph, whatever. You do it all with System.drawing, and that works cross-platform on all the platforms. I wish they'd finish this up. Fusillade is another one that I just found out about. It's by Paul, and it's really nice for HTTP, asynchronous fetching of things, automatically making sure that if somehow you get 2 requests for something, that it only gets 1 request. It does caching. It does a lot of cool stuff. Check it. Those are all free. They're all on GitHub, and they're all portable class libraries, so you can use them in all projects. People have done a lot of good work. Tips. Bait and switch PCL trick. This again is a blog entry by Paul Betts. It's pretty cool. I would recommend reading it if you are going to do things with portable class libraries. Basically what he ends up saying at some point is that while you can't call certain APIs because of the profile in a certain PCL profile, you can, there's some tricks which allow you to basically call other APIs and lie to the portable class library, and then as long as when you actually run it and connect on the platform that API exists, then it will do the right thing. It allows you to basically get around always having to wrap some of the things in services and then expose them through the dependency service. It's kind of mind-blowing. It's only like 2 pages long, but it's a neat trick. One of the neat things that Xamarin does is they do give you a platform-specific set of APIs that allow you to do some handy things. So this is just one example of one of the routines that they have. Device on platform, and you provide 3 lambdas. So Android, Windows Phone, iOS. So you create these things where you might need to do something specific on each of the platforms, slightly different. You know, colors should be blue in the, what is the new Android thing? I forget what it's called. Material. That's a new UI. And, you know, padding around UI controls, things like that. This is a good way to do that. So as Dale mentioned, and as I mentioned, this is a really nice GitHub open source project called Xamarin.Forms Labs that some guys have started. And basically the whole idea is to come up with far more controls and services than are currently provided by Xamarin. It's, you know, it's all lit up as beta right now, which means basically we've written it, we just never tested it. So there are a lot of nice things that they have, and it's got a lot of commits and it's happening pretty quickly. Services are nice, so basically these abstract off, and some of these all call through to, Xamarin already has a framework for doing some of these things, and some of these call into those, but it allows you to get access to platform-specific things in a platform-independent way. These are available in BVM helpers that just allow you to do BVM with those things. And they have these plugins, which is back to the IOC, for caching, dependency injection, tiny IOC, which I've used. I've used these 3. I don't think I've ever used these 2. This one is nice. It's tiny. This one allows you to do all kinds of cool stuff. And I think when I checked it last, it was faster than this one. But that allows you to do much more sophisticated dependency injection. Web, if you want to get to some REST resources. Charting, they've got some basic charting stuff, but there is another, which I put in here, there's a cross-platform library called Oxyplot that allows you to do plotting on all the different platforms. Alas, it is not written in a portable class library way, so you have to have a copy or a project for each of the platforms you want to use. Serialization, which is good, service stack JSON.NET I've used a lot, it's really nice when you want to take data structure and pop it JSON or good JSON
We've
into
been
it.
looking at Jill for JSON serialization.
Which one? What's it?
Jill,
I haven't seen that. What's,
it has, it's built on, was it Sigil? And it uses a lot of IL behind the scenes to drive the serialization. It's actually significantly faster than
yeah.
JSON.NET.
There the problem though,
It
a
won't
lot
work
of them
on
that do the,
Xamarin.
it won't work on, it will work on Xamarin, it'll work on Android, it
Right.
won't work on iOS.
Right.
There are a lot of, and that was the problem with several of the IOC ones too, is that in order to make things go faster, they do IO injection. Yeah. You can't, iOS doesn't allow you to generate or manipulate code or change the code pages on the fly. So you can't use anything that's actually going to generate live code. So luckily that has been less of a problem than I thought when they first came out with it. Definitely check out this project if you're going to do any Xamarin.Forms because they're going to have some cool stuff up there. This was a demo I already gave. Let's see
To
here.
answer your question, I looked at the code, it looks like the animation's done in C#. It's not easy.
It's not using core. I didn't think it was using core animation. And again, it's probably fine as long as you're not animating 100 objects or something. Although I did some stuff where I did some text animation, a little app, and I was doing it by just creating a text label for each letter. And I had like 50 letters and I had them flying around the screen. And it went kind of slow. So you really need to use something, I mean, it's okay, but you really, that's what core animation is built for. It basically optimizes the animation. This will give you an idea of the different, this is a project they have called Forms Gallery. That was, yeah, I forgot that popped up when I was doing it. Ignore that. This shows you each of the different controls, basically. They have box views and box. Web view allows you to include a web page. Map, like it says, platform-specific maps. Button binding. This thing basically looks identical on each of the different platforms. It's the same code for each of the platforms. You have a small amount of code. You have to have a project per platform, one for iOS, one for Android. That typically you don't have a lot in that project, but that project calls over into the portable class library that has all this shared code. So you're kind of bootstrapped. That gives you an idea. I don't know why the date picker and the time picker weren't actually doing anything. I'm not sure what's going on there. Those are actually showing me text points. I'm going to move this video. Single entry text, multiple lines. So again, the beauty of this is that you've got, the majority of UI controls that you need to generate at least a prototype, if not a full finished application. You can customize each of the controls to some extent by colors, various other things. But again, if you want to create your own controls, you have the ability to do that. But in some respects, it's a lot simpler. Because I actually sat down before and wrote a bunch of iOS code, wrote a bunch of Android, and the way you do things with activities and all these things is very different than iOS, and then Windows Phone has its own thing. And trying to juggle all three of those things in your head can get to be a real pain. So actually the beauty here is you can learn this one thing and then get most of the things to work cross-platform. You're going to have to dig down if you create a custom control, but typically you won't have to. Here's the stack layout. Absolutes, just they're screwing around with the that's again the animation, just changing the XY positions of those. There's a grid. Relative layout allows you to do complicated things. Content page, navigation, navigate, go back, navigate, go back. Master detail page. This is the slide to the side, go pick another menu, now we're over there, slide to the side. This is sort of initially made popular on the iPad, and then people brought the concept of the hidden menu back down to the phones. That was a tab, carousel page, which is like called a panorama or something over on Windows Phone. And that basically gives you an idea of, it gives you all the controls that you have. Okay, F# and Xamarin.Forms. So if you want to be more on the bleeding edge, need the relatively latest version of Xamarin Studio, which you should be running anyway for all the rest of this. I'm running the latest F# plugin. That's later than the one that's published by Xamarin, but you can actually go to GitHub and you can download it and build. Well, there's the plugin for Xamarin, and then there's the F# compiler itself. And both those are real simple to build. It's simple to build on the Mac, not as simple to build on Windows. There are no templates yet for, I want a new F# Xamarin.Forms project. So basically, you have to find someone else's, go open the project, and do a little bit of XML editing, which is not as bad as it sounds. You have the two secret sauce things that I was missing before are basically that there's a version of F# Core. F# Core is the, it's like the MS Core Lib for C#, but it's the one for F#. You have to have a special build of that is basically built for the PCL78. And that is up on NuGet, or Nugget, what you like to call it. So you have to pull that guy down, you have to delete the old F# Core, and you have to put this one in. And then you have to link to the facade assemblies for MonoTouch. So under your Xamarin installation, somewhere down in there is this folder of all these assemblies. And what these assemblies do is, for PCL78, when you're doing an iNotify property, it is in, I don't know, system.something, I forget what it is now. Over on 4.5, it's in system.component.model.something. Over on iOS, it's under system.da. These things basically know that all the platforms have the iNotify property. It's all the same on all the platforms, but a long time ago, someone made a very bad decision and put them in different namespaces. So if you try to build without these, you'll get all these things, but you can't find these things. So basically, these little assemblies are basically, they're just vectors. They say, okay, here, you've got this, and then it actually figures out a runtime that finds it. There's no actual overhead, platform overhead to that, but that was the biggest. When I tried this a couple months ago, I'm like, okay, it's the work, and that was the secret sauce. This blog entry talks about that too. Again, simplest way, and when I get a little bit more F# time outside this contract I'm working on right now, I'll try to put some stuff up on GitHub, some sample projects. If you don't do these things above correctly, you will get things like, I can't find iNotify property change, I can't find a lot of really simple things, and it's a combination of these two things, mostly the facade assemblies. F# does not have a concept of what's called shared projects, which are different than portable class libraries. If you don't know what they are, don't worry about it right now. You can't use them anyway. And I'm not even sure if F# ever will have them. There are some issues with that. I've talked to a few of the people, and they may eventually come, but you really don't have to use them, and you're probably better off if you don't use them. Go for portable class libraries if you can. Here's an F# example. Oh, that's good. The screen is not full width. So you really can't see it there. But essentially it looks a lot like the C# version. It's just F# instead. So, I mean, you can write it just the same way. So this is one that just basically puts a hello F# Xamarin.Forms in the middle of the page. But since you can't see that, I'll have to look at it up on the, I post when I get up. But you can play that, it works. I've done several things. It all seems to work just as well as it does with C# now, which is good. They're getting up to parity. And that's it. I'm done. There's my contact info. I will put this up on our GitHub repo, and I'll put the video up on YouTube and link that into our Twitter handle. And questions?